So as we move further into our polynomials, we're now going to say write a quotient with, notice how it says positive exponents here. So that's an interesting thing. What do they mean by positive exponents? So one of the things we pick up in math is a negative exponent means to take the reciprocal. So if I have 2 to the negative 1, 2 to the negative 1 means the same thing as 1/2. If I have 3 to the negative 2, that negative exponent means to flip it. So notice when I flip it, it becomes a positive exponent, 1 over 3 squared, and then 1 over 3 squared would be the same thing as 1/9. So one thing we pick up on, a negative exponent means to take the reciprocal. So if I have a to the negative 1, a to the negative 1 is going to be the same thing as 1 over a. Now, another thing we pick up on, though, is if I have 1 over a to the negative 1, notice how it's already in the denominator. To take the reciprocal means this just turns into a. So if I have a negative exponent in the bottom, it can move to the top as a positive expression. So if I have like 1 over x to the negative 2, that's the same thing as x squared. Those are interchangeable. So this, when there's a negative exponent on the bottom, I can move it to the numerator and it becomes positive. Again, I could write this as x squared over 1, but x squared over 1 is the same thing as x squared. So notice how I can flip it, put the 1 on the bottom and move this to the top. But when I move the negative exponent from the bottom to the top, it turns into a positive exponent. So negative exponent is pretty special as well. So those are some special exponents that we have to deal with. So right now we have positive exponents. Now, notice how n to the sixth means n times n times n times n times 2 more n's. N to the third means you have n times n times n. Now, remember in division, recall, just using actual numbers, 2 divided by 2, anytime you have the same number on the top and bottom, notice how 2 does go into 1 time. So what we've learned is, if the numerator and denominator are equivalent, then that just turns into a 1. So if you have x over x, x over x is the same thing as 1. So what we pick up on is these n's, n over n is going to turn into a 1. N over n is going to turn into a 1. N over n is going to turn into a 1. So in other words, what we're going to have is like 1 times 1 times 1 times then n times n times n. Notice, since the denominator divided out, there is no more denominator because it would be understood to be a 1. So we can just drop it. But also notice that when you multiply by 1s, they just drop out of the problem as well. So really, what this boils down to really is just n times n times n. In other words, you have n to the power of 3. So what we pick up on is a shortcut. In a quotient, if the bases are the same, you can just simply subtract the exponents. So there's a rule that says this. If you have a to the m divided by a to the n, notice how if you have the same bases, you keep the base and you're allowed to subtract the exponents, m minus n. So for our problem, the shortcut is if you have x to the sixth divided by x to the third, notice how we have the same bases. So what I do is I keep the base and I subtract the exponents, 6 minus 3. Well, 6 minus 3 would be just simply 3. So that's where I would get then this x cubed. So again, notice how we're working with a monomial, a single term expression. So notice how n to the 6 is a monomial and we're dividing by another monomial. And to simplify that, this one in particular, we just keep the n's and subtract the exponents. So this, you can do it the long way by just using the math that's in front of us, but we prefer to use the rule to simplify the expression.